Question 3. This question is about group 2 elements and their compounds. A chemist adds 0.115 grams of a group 2 element to water, and the resulting solution is made up to 400 centimeters cubed by adding distilled water. The equation for the reaction is shown below. The M represents the group 2 element, so we've got a general equation there seeing group 2 reaction with water. The concentration of hydroxide ions in the solution is 6.56 times 10 to the minus 3 moles per decimeters cubed. Determine the molar mass of M to 1 decimal place, and then identify what M is. So there's a lot going on in this question. And for only 3 marks, arguably that's quite stingy. But just you have to bear that in mind. At this level, at A level, you're going to have to do a lot of legwork sometimes for not a lot of reward, especially on some of the multiple choice questions you should encounter later on in the course. So let's just take stock of all the information that's important here. All right, whenever you're approaching a calculation, your focus should be on the numbers that are present and what they're relating to, and try and order your thoughts, try and organise what's going on in your mind. So we've got 0.115 grams of a group 2 element. Okay, without knowing the group 2 element, therefore knowing the MR, I can't work out a number of moles using that mass. Okay, so that's going to be of no use to me whatsoever to start off with, but it will become valuable later on. So let's carry on reading. Made up to 400 centimeter cubed, again, without really knowing what this is, I can't, the 400 is not going to give me too much information at the moment. The equation for the reaction is shown below. So we've got a ratio 1 to 2 for the metal to water, 2 to 1 for the water to the hydroxide. Okay, the concentration of hydroxide ions. Right, okay, now we're getting interesting. It's specifying the hydroxide ions because we don't know what M is, but we do know, because group 2 metals have got a 2 plus charge, that the hydroxides will be a 2 to 1 ratio within the chemical itself. So for every one group 2 metal ion, there will be 2 hydroxides. And I've got the concentration of the hydroxides here. I've also got a volume. So now I can start to put things together and make some calculations. Determine the molar mass of M to 1 decimal place. So I know the quantity of hydroxide ions in a certain volume of the solution. Okay, so by reacting my group 2 metal with water, with this volume of water, and making my hydroxide, I now know how many hydroxides are present in this solution, so I can work out a number of moles of the hydroxide ions, not the MOH2, because I don't know what M is, but I can work out moles of the hydroxides on their own. So let's look at this then. Moles of the hydroxide ions is concentration times volume over 1,000. Concentration, 6.56 times 10 to the minus 3. Volume is 400. Over 1,000 gives me a number of moles of the hydroxide ions of 2.624 times 10 to the minus 3. That's a 6. Okay, so now I've got the moles of just this bit, I can actually now work out the number of moles of M. Okay, the number of moles of the metal, which is important. I need that to be able to use with alongside the mass to work out an MR. So this is where you've got to be careful. The ratio of M to MOH2 is clearly 1 to 1. There's no balancing there at all. But what we have done here is worked out just the moles of the hydroxide ions. And for every one of M, there are 2 hydroxides. So not only when you, can you get ratios within full molecules, 1 to 2 there, for example, you could also get ratios between parts of the equation as well. So be mindful of that. It's a little trick on the calculations that examiners like to chuck in every now and again to make sure you're still paying attention. So here we have a 2 to 1 ratio in terms of the hydroxide ions to the group 2 metal M. So therefore, the moles of metal M is going to be the moles of the hydroxide ions, 2.62 times 10 to the minus 3, divided by 2 to 1 ratio. So the moles of M will be 1.312 times 10 to the minus 3. Now, because I've got a moles and I've got a mass, I can work out the MR of this element. So MR is the number of moles, sorry, I beg your pardon, the mass divided by the number of moles. The mass then of group 2 metal is 0.115, as stated in the question there. Dividing that by the number of moles of M, 1.312 times 10 to the minus 3, gives me a molar mass of 87.65. So we're told in this question here that the molar mass needs to be calculated to 1 decimal place. So we've worked out at 87.65. So we need to round this to 1 decimal place. So that's going to be 87.7 to 1 decimal place. Make sure that goes on the answer line correctly. And then to identify what M is. Now we know M is a group 2 element. So if we bring in the periodic table, looking at group 2, we're looking to find the element with the atomic mass close to 87.7, and therefore there it's already circled, it's strontium 87.6. So the answer and the identity of metal M is strontium.